Hi there. In this video, we're going to talk about what exactly is a determinant. So a determinant is very important in linear algebra and calculus and many other applications of math. But where exactly does it come from? So this video is just going to give just a very simple overview of where a determinant actually comes from. So the way we start is just by considering a simple system of two linear equations. 2x plus 3y plus 2 is equal to 0, equation 1, and then 3x plus 4y plus 6 equal to 0, equation 2. So in high school, people would have solved this system of equations just by eliminating one of the variables. And in this instance, we can eliminate y. And how we would do that is by finding just the lowest common multiple of 3 and 4, which is 12. And we would multiply equation 1 by 4 and equation 2 by 3. So we take equation 1 and we multiply it by the coefficient of y in equation 2. That's 4. So now we have 2 times 4, which is 8. We have 8x. And then we have 3 times 4, which is 12. That's 12y. And then 2 times 4, which is 8. And that's equation 3. Then now we take equation 2 and we multiply it by the coefficient of y in equation 1, so that's 3. So equation 2 times 3, and then 3 times 3, that's 9. So we have 9x. Then we have plus 4 times 3, which is 12. So we have 12y, and then 6 times 3, which is 18. That's equation 4. So how we would now proceed is by just eliminating the variable y, and we would take equation 3 and subtract equation 4. So we take equation 3 minus equation 4. So 8x minus 9x, that's just minus x. And 12 minus 12 is 0. And then 8 minus 18 is 10, minus 10. That's equal to 0. So we can see that x is just equal to minus 10. So what does this have to do with determinants? How do we get determinants from all of this? So how we do it is now we're going to do this exact same procedure, but we're going to do it for generalized coefficients. We're just going to remove these coefficients 2, 3, and 2 and make them general. So the coefficient of x, we'll call that a1 and a2, equation 1 and equation 2. And then y, it'll be b1 and b2. And then for the number, it's just d1 and d2. So we proceed as before. We take equation 1 and we multiply it by the coefficient of y that's in equation 2. So it's a1 times b2. So when we do that, we get a1 times b2 x, then plus b1 b2 y plus b2 d1. That's equal to 0. And then now we take equation 2 and we multiply it by the coefficient of y, that's equation 1. So it's b1. So it's equation 2 times b1. So now we have a2 times b1 x, and then plus b2 b1 or b1 b2 y, then plus b1 d2. That's equal to 0. So now all we need to do is just subtract these two equations as we had done previously. And when we do that, we can take x out as a common factor. So we have x into, so it's a1 b2 minus a2 b1. And of course, y's, when we subtract them, they become 0 since the coefficients are the same. And now we just take what's left to the other side and we just subtract them. So what's left is b1 d2 minus b2 d1. And we can solve for x just by dividing both sides by the coefficient of x, which is a1 b2 minus a2 b1. And that's what x is equal to. So where does the determinants come into place? Well, looking at the numerator and denominator of these terms, these two are determinants. Both the numerator and the denominator is determinant. We have literally just seen where the determinant comes from. Let's just look at the denominator. If we isolate the first two terms of our system of equations, a1, b1, a2, b2, and then we just write it out. So we have a1, b1, and a2, b2. It is a determinant, so we show these vertical lines to indicate that it is a determinant. And where it comes from is you can see that we have a1, b2. So we have a1, and then we multiply across diagonally, so it's a1, b2. And then we have the minus, because that's the second part of the determinant, second term. The minus is always there. And then a2, b1. So there's b1, and we're now multiplying it by a2. So what we have seen here, gotten here, is the determinant by isolating these first two terms of this system of equations. And then the numerator is also a determinant. If now we isolate just the second and third terms, and we just write it out. So we have b1, d1, and we have b2, d2. And then we compute a determinant as is usually done. You can see that we have b1 times d2. We multiply across diagonally. So there's b1, d2. And then minus second term of a determinant, then b2, d1. So there's d1 times b2. So both this numerator and the denominator are both determinants. This is where determinants come from. And this is exactly what it is. It's just a factor. It's just numbers that's computed using these coefficients of these variables inside these linear equations. And when we take some kind of combination of these factors, these determinants, we are actually able to get the solution of this system of equations. So that is the power of determinants, and this is literally where it comes from. When we take a system of equations and we solve for it, we get some kind of result that's in terms of these coefficients. And grouping these coefficients in a certain way is kind of like a factor, and that factor is what the determinant actually is. And we can just use this general result to calculate this system of equations. We can just go back to the first example that we started off with the numbers, and put them back, and then when we do that, using this formula of this determinants, we should get minus 10 as the answer as we had seen. So our original system of equations was, we had 2x plus 3y plus 2, and then we had 3x plus 4y plus 6. And we had seen that x was equal to, firstly in the numerator, we isolate this second and third terms, and we make a determinant out of it. So we have 3, 2, and then 4, 6, and we are taking the determinant, and then we divide it by the first two terms, the coefficient of x and y, and we make a determinant out of that. So we have 2 and 3, and then 3 and 4. We write it in the notation that we have just shown now, and we just compute this determinant. So it's 3 times 6. Recall that we multiply out diagonally. So we have 3, and we have 6. And then we're now subtracting second term of the determinants, then 2 times 4. We have 2, and we have 4. Then now we divide this by 2 times 4. Multiplying out diagonally, then minus, then 3 times 3. So if we just calculate this, 3 times 6 is 18, minus 2 times 4, which is 8. Then we divide it by 2 times 4, which is 8, and 3 times 3, which is 9. So we had 18 minus 8 divided by 8 minus 9, which gives us minus 10, which is what the solution was to our original system of equations that we had, which we had done manually. So this is just an illustration of the determinant and where it comes from. It's just a coefficient, it's just a number, a factor that's calculated using these coefficients of these variables. And now we're going to extend it in the upcoming videos to a system of 3 equations. And then as we go more into linear algebra, we'll see many other applications where it's required. So thank you very much for watching.